Hi everyone, good morning. I hope I'm audible.
Good morning. Yes.
Okay.
Good morning.
Anybody new who has joined or listening me for the first time? Okay, the recording's not shared, so I'll check with the front office. If it is not shared, then I'll ask them to share. Okay, so we are waiting for few people to join. Meanwhile, anybody has any question or anything they would like to discuss? All right. So if there's no question, then let's move ahead. So from past couple of classes, okay, days, we kind of discussing, what exactly is data science, and I'm kind of trying to explain you like how this data science can help you to, secure your career and future in terms of having more opportunities or having getting better, uh, job satisfaction and all. So if anybody has any queries around that, people can feel free to ask those questions. Today we are going to dig deep into this subject and we will understand some more concepts, okay, high level concepts, and we will also get I will also try to explain you some of the real use cases which you can relate. Okay, though we have tried yesterday in identifying some of our real experience in terms of experiencing any AI solutions. But here I will show you some of the real use cases which where you can use data science and AI. Okay, so let's get started. So this is where we stopped yesterday, and data scientist we discussed what this guy does. Okay, so machine learning. Okay, so now machine learning is a subset of data science, and this is also one more different area or different subject which you have to learn. Okay, if you want to become a data scientist, and this machine learning is a subject which helps you to extract the knowledge from the data. We discussed, right? The data contains information and the knowledge. Information we know how to extract. We can build charts, we can build reports, we can use some basic aggregation techniques, to come up with some information. But when it comes to extracting knowledge, things will become little complicated. Okay, things will become little complex. So why we call this particular area as machine learning? So definitely knowledge and learning, they are kind of interrelated. Anyone cannot acquire knowledge without learning, right? So here the machines cannot become knowledgeable without learning, right? So these are the techniques, these are the algorithms which falls in this particular area of machine learning, helps the machines to detect the patterns, detect the relationship, and to acquire that particular knowledge from the machine, from the data, okay, through some kind of learning. So this whole process of extracting the knowledge is considered as machine learning, and you have different kinds of algorithms in machine learning which you can use, to perform that task. Typically, machine learning has is of two types. One is supervised learning, another is unsupervised learning. A supervised learning means in your data, basically what you're doing is you're giving the input variables and the output variable which you want to predict. This y is known as target variable or the output variable. X is considered as the input variable, or we call as features or predictors. There are different names, okay, which you will see in the course. So if you want to predict the output variable based on the input variables, and you are feeding your historical data to the algorithm saying that, okay, when your input variable was was your output variable. So here you are kind of uh, giving some kind of a supervision to your algorithm to learn, okay, when X is like this, Y is like this. It is just like, in during our college days, graduation days, we used to refer to a lot of question banks, right? So where there is question as well as answer, okay? And based on that question and the answer, we will able to learn like, okay, if this is a question, like this is how, you should respond, okay, or how you should solve. Similarly, here also in these kind of algorithms, these algorithm requires the input variable as well as the output variable to understand the relationship between the input and output. Now, if you are having a problem like that, okay, then you have to use a supervised learning techniques, okay, to solve that particular problem. In some of the cases, okay, you do not have this output variable. Okay, when we talk about real use cases, you will able to understand. But by now, just understand, okay, in some of the cases, you will not have this output variable, which you want to predict. You will just have input variables. It could be one or it could be more than one. Okay. Now, with this input variables, if you want to derive some insights. So for example, I'll tell you about a simple problem. For example, you want to create clusters. Okay, you want to come up with the clusters, you want to come up with the groups. So based on the person's attributes, okay, I want to create a groups, homogeneous groups. So there are certain clustering technique in machine learning, which you can use. What it does is it will identify the patterns or the attributes of every customer or every person, and whoever are having the similar kind of characteristics or similar kind of attributes, it will go and put them into one single cluster. So here you are not dealing with input and output, and you are not even supervising the algorithm saying that this is the input, then group them into this cluster. If this is the attributes, group them into this cluster, because that cluster information, that group information, you do not have in your data. Okay, so now this grouping or this identifying the cluster, this algorithm has to do by itself. So that's the reason it is called as unsupervised learning. So majorly, the algorithms has been categorized into supervised and unsupervised. And based on the problem, based on the data, you have to choose, which particular technique you have to follow. Okay. So by now you might have understood why machine learning, it is called as machine learning. And in machine learning, what do we mean by supervised learning and unsupervised learning, right? So to now these machine learnings, these are state of the art algorithms, and you will be amazed the way, these algorithm has been discovered and been, hats off to those scientists, who have kind of came up with these kind of approaches. So they have related all these machine learning algorithms which are real life. When we will go through those algorithms, I will give you a very realistic scenario, the way we make decisions in our real life, and you can relate that with that algorithms, the how it works. So very much similar to our human brain, our human personalities, how we think, how we kind of approach to any decision. Similarly, these algorithms have been structured in those way. Okay, so very interesting. A very good, I would say, very great discovery in this space. Now, the kind of output which people were getting out of this model was very much relevant and very much closer to the way the humans were making the decisions. So that's the reason the even the adoption was quick. People started finding these algorithms or these models to be very useful, and they started consuming that into their businesses, okay, into their processes. And that's where the whole trend got changed, and people started focusing more from statistical models to machine learning models, which are more mathematics driven models. Okay. And even this computer programming and the infrastructure, okay, also has also further helped these models, to get more traction. Because see, once you adopt, and if it is like difficult, to maintain, to build, and to use, then people will not adopt. So these computer programming, again, there was a huge, I would say, evolution happened, in the information technology side also. Their latest, more efficient way of programming has come. Okay, so you can train these models even much more efficiently than before. Firstly, there was R programming, which typically the data scientists were using, which was more of a statistical, I will call as a statistical software or a tool, for doing a lot of analysis. But where it failed miserably was, for scaling. Okay, so when larger data, when it is passed to this R tool or R software, it couldn't able to scale that well, and it was either crashing or it is taking a lot of time, to process and all those things. So that's where this Python came into picture. So Python slowly it got evolved so much now. Okay, you will find every damn thing in Python. So there are so many libraries available. You can scale, you can run different kinds of algorithms, and even in the big data tools like Spark and Hadoop, there also you can use Python. So looking at that, so Python has gained a lot of popularity, and a lot of traction in the market, and a lot of challenging tasks which were earlier hampering the whole development life cycle. So now it has become it has resolved through this Python. Okay, even the integration was seamless. You can integrate the solution with various applications and different technologies easily by using Python. Okay, so now that's how this machine learning got a lot of adoption, and people started training the models and even the infrastructure, as I mentioned. Okay, so now over the cloud, it's easy, to choose any kind of instances, any kind of a VM. Okay, and you can able to scale your solution to that level. Definitely, your statistics is everywhere. Okay, so it is not like you have two different distinct disciplines like mathematics and statistics. There would be a mix of both. But in statistical models, it would be too much of statistical heavy, less of mathematical concepts. Okay, but when you get into these machine learning algorithms, it would be more of mathematical concepts and less of statistical concepts. Okay, and typically people say that, okay, let's suppose there is two major areas. One is statistics and another is programming. Okay. So the person who is very good in statistics will become a statistician. Okay, a person who is very good in programming will become a good software programmer. Now, data scientist comes somewhere in middle. Okay, he should have a good statistical knowledge, a science knowledge, and should also be a good programmer. Okay, so that's how he balances between the two. Okay, and even when you are getting a job in data science area, then you have to kind of tackle the both. You have to understand, because these two fields are evolving too much. You will see a lot of discoveries are happening on the science part. People are discovering more new algorithms. They are coming up with new different concepts and approaches, to solve different kind of problems. And same time, that even the IT is getting much matured. Okay, so there are different tools are coming, different programming languages are coming, and even in programming languages, there are different kinds of libraries which is being built in. Okay, so as Python is a more open source, so the community is the community is very wide. Okay, for Python, you will find so many libraries available. So instead of building anything from the scratch, you will just look out for that library if it exists in the Python community or not. You just need to install, and you can use that library to perform your task. So on the programming skills also, you have to be always be updated, and you have to keep upgrading yourself. So you need to have a right balance of statistics and computer science, to understand machine learning. Okay, statistical learning, I'll skip. Okay, so artificial intelligence, we spoke a lot. Okay, it requires a lot of things. It goes, as I mentioned, it goes extra mile, and it is a congregate of multiple things. Okay, it includes linguistic, philosophy, psychology, neuroscience, mathematics, computer science, a lot of other things also. Okay, so just imagine. Okay, you might have seen a robot named Sophia, right? It is a very till date, nobody has developed a robot like that. It looks like completely human. Okay, the expression, the way she talks, the way she gives emotional uh, faces and all those things, facial expressions. It is very much similar to humans. And based on that, even the Saudi government, they have given the citizenship, to that particular robot. So they consider that robot as a human being, and they believe that it is part of their own country, and they have given the citizenship. So that robot has everything. Okay, as we have Aadhaar card and everything, even that robot has. So just imagine, to build that kind of a robot which is completely driven by artificial intelligence. It is not a one person's or one team's job. It is a bigger. So there is a whole company, who has developed that entire robot. So it requires a lot of skills. So do not get carried away if somebody is saying that, come, I will teach you artificial intelligence. Okay. That's the reason I always call this course as a data science course. From the data science aspect, I'm covering most of the part. When it comes to AI, I may not cover every aspect because it is beyond my knowledge, it is beyond my skills, because I can just only teach you the intelligence part, which comes from data science. How to train the models, how to bring out the knowledge from the data, which would help these AI tools and applications to make decisions and to react and to take actions. That's something I can teach. But how it will fit to the bigger picture, like how the AI would run on the website, how the AI can be turned out to be an self-driven car, then how this AI can be used, for building an intelligent or smart machine. So that something is a bigger picture. Okay. So even for developing a chatbot, I can build some simple chatbot in my computer, and I can show you running. But in general, the bots are not used in that way. The, those chatbot has to be properly integrated with all the upstream and downstream applications, and it should be properly deployed on the website. Even the UI should look good. Okay, all that thing is required. So for that, you require a broader skills, and it's not a one single person's job. Okay. So here, to develop any AI application, you need to have some kind of a predictive model, um, which can extract the knowledge from the data and use it as an intelligence. Okay. So, and we just now we have seen that machine learning is such a kind of an area. Okay, through which by using machine learning, we can able to extract the knowledge from the data, and that knowledge would be useful for building an AI solution. So that's the reason machine learning is considered as a subset of AI. Okay. If this is AI, then machine learning is a subset. Okay. So we discussed a lot about this AI in the previous classes. And you might have also be hearing about a word known as data mining. Okay, it is just like I believe this is just a synonyms, okay, of data science. But when you talk about when people talk about data mining, one more skills they may expect, okay, from data scientist, which is databases. I will call it as a data repositories. See, when you are, see, you have to relate. See, most of the things you will able to understand if you break the words and if you understand the meaning of each of the words. Here, data we know. Here we have to concentrate on this word mining. What is mining? Okay, so mining is all about like you go deep into the earth, okay, and you mine some or you extract a precious resources. It could be water, it could be oil, it could be what do you call minerals. Okay, so mining is all about how well you can go deep and you can extract some value. Okay, here data mining, now you relate how it's all about how deeply you can get into the data and you can mine a or you can extract a value out of it or derive meaningful insights out of it. That is known as data mining. So it is very common. Now you can relate with data science. Data science is almost like it's the same definition. It is not nothing different. They are also data science. We understood that it is all about extraction of information and knowledge, right? But now they have coined another word, data mining, just to give more importance to the databases and the data repositories. Now data would be sitting somewhere. Now, even before bringing out insights, firstly, you have to go and extract that data first, and then only you can extract information out of it. Now, if the data is kind of scattered across multiple disparate data sources, then how would you extract? You should have a knowledge of those databases, right? You should know, how to acquire that data, from multiple sources. So that skill will also be part of data mining. Okay. So I would call it as a data engineering plus data science together is considered as data mining, because here even the data extraction becomes a key element. Okay. All right. So this we have discussed. This we have discussed. Okay. Now get into some examples. So there are millions of solutions. Okay. In my career also, I've developed or I've been part of several solutions. So, but today in this course, I just picked up few different kinds of use cases, which I will talk about, which will give you some idea about the application of data science. The application of data science is very, very critical, guys, and it is very important to you to become a good data scientist. If the application part of it, so we also called as applied analytics. We also called as applied AI or applied data science. See, science, if you know about the science, but if you don't know how to apply that science, then that knowledge is of no use, right? So the application is very, very important, and you should understand how to apply these tools, these techniques, okay, to solve any particular kind of problem. So, for example, customer analytics. This is the one of the solution, which will help you to find out lot of information. Just a So, for example, a data science application means, okay, how you can solve business queries or business questions, okay, or business problems. That is known as application, right? Firstly, you need to understand the business. You need to understand the domain. You need to understand, what problem, what questions the business is having, and then you have to apply your data science knowledge and techniques, to come up with the solution around that. So, for example, Now here the business is having a question like, who are my most valuable customers? What are my most important products? What are my most successful campaigns? So these are the questions, it is all about what has happened, right? If you remember our initial classes, okay, there we discussed like, if somebody has a question related to past, if the business wants to get an answer related to their past, like what has happened, okay, they can go ahead with descriptive analytics. So now what you are doing is you are understanding the problem statement and then you are slowly translating that into an analytical problem. Now you have to understand what questions the businesses are having, and what could be the right technique to solve that question. So here, all these questions seems to be that they want to have some kind of information related to the past data. Who are my most valuable customers? If I look into the historical data, I can able to identify who are the valuable customers. The customers, who have done more transactions, who have given more business or more revenue. Okay, those customers are most valuable. What are my most important products? Again, which are fast moving, which is giving more profits. Those are the most important products. So I'm translating these generic questions or the most in business terms to a technical term. So here I'm coming up with the KPIs. Okay. So more frequency. Okay. More revenue. Okay. So these are the KPIs, and that I will attach to the customer, to identify the most valuable customers. Here, important products again, the profit, okay, or the fast moving means number of transactions for each of these products, and what are my most successful campaigns. So campaigns in the tense again, which is generating more revenue or which is generating more customers, those could be the most successful campaigns. Again, I have to identify the KPIs. It is more traffic or more hits or more views or more impressions or more revenue. How the business would call or would define any campaign as a successful campaign, that I want to understand. And that I will kind of map it with the data which I have. Then I will go back to the data and I'll see that whether all this information, all these data, all these columns are available in the existing data or not. If not, then I will look out for, I'll go to the business, I'll ask that I need this kind of details. Can you provide me? If it is not there, then I have to look out for some other way. Okay, if it is there, then I will go and extract. I will put some business logic. Okay, some business logic. Okay, to convert that problem statement into a technical problem, and then I will go and solve that particular problem. So here, if you see, this the entire problem can be solved through descriptive analytics. Okay, so I'll just take the relevant data and I will aggregate it. I'll transform that data. I'll do some kind of pre-processing and put and apply some business logics, to come up with the answer. Okay. So this, and you can relate it with any kind of business problem. Okay. Even it is at the operation side. If the business is into logistics, so they want to see like how many customers they have delivered on time, how many customers, they have failed to maintain, or the SLA, how many deliveries they have done so far, okay, how many trucks they have used, what is the overall cost, okay, what is the profit. So these kind of questions can be answered, with the help of data by applying descriptive analytics. So that's one. Now comes get into predictive analytics. Okay. Now, I think this you can relate with your real life. For example, it is for e-commerce business, and I think everyone has done some kind of online purchase, right, in some form or the other. So let's suppose you are running a online business, you are running an e-commerce website. Okay. Now, what you can do, because in the stores now you relate. If you have a brick and mortar business, like where you have a proper retail store, in that retail store, if any person is coming, you can see his face, you can see his body language, you can ask questions, you can convince them, you can show them different products. Okay, and then you can persuade that person to buy a product, right? But in the online, how you will do it, you can't see that person, you can't understand whether how serious that person is. Okay, what he's looking for. You can't even ask questions, right? He will come, he will look out. If he likes, he will buy. Otherwise, he will drop, right? But so how I can generate more revenue? So there again, you can use some kind of data science way. So here, let's suppose, you may get a very innovative idea saying that, okay, I can predict, okay, whether that person will buy the product or not, whether he's serious or not. I'll make some kind of a prediction. Okay. Let's suppose in this case, you are running a business where you are selling smartphones, right? So now, if you can somehow predict, how serious that person is in terms of buying a smartphone, okay, what you can do, you can take certain actions, right? You can immediately offer some chat help. You can say, hey, I'm being observing you. Okay, so you're looking out for smartphones. Can I help? Okay, so there would be some chat. Okay, either it could be human agent or it could be a chatbot. Okay, and now with that conversation, probably he may say that, yes, I'm looking out for this particular model. I'm unable to get it on your website. So you'll say, okay, fine, I can help you out. Okay, this is a link. Please look at it. Probably if we get exact match, okay, he may go and buy that particular product. So here, instead of investing too much, what I'm doing is I'm kind of automating the process. I don't want the humans, to decide whether the person is serious, because it is not possible also. You cannot chat with every person, who is entering onto your website, who is logging onto your website. Because just imagine on Amazon, okay, how many people kind of log in, to buy a product. Okay. So to every person, if I assign one agent, it is not possible. It will be very costly. So there would be some people who would be doing window shopping, right? You might have seen when you go into malls, like people just roam around, they don't buy. Okay, they'll just say, okay, show this bhaiya, show that bhaiya, and they will go away. Okay, they will not buy anything. So no point wasting time on those people, right? Putting one salesperson, to convince them, to persuade them. If I have 10 people, if I am a store manager, I will say that, okay, concentrate on those two guys because those two guys look serious. Okay, other people, I think they have just come for window shopping. So similarly on the e-commerce business, okay, there also it is important for you to identify whether the person will predict will buy or not. Now the question comes, how it can predict, how to build that kind of smart application or smart solution. So if you look at the historical data, okay, in the historical data, if you identify some patterns, like person coming onto your website, firstly from where they are coming. If somebody is searching for a product on a Google, okay, Google search, and through that, if they landed onto your website, okay. So in the past, if people have done like that, most of the time, the people have made the purchase because they are very serious. They are very targeted that I want to buy this particular product, and they did the search and then they landed to your website and they purchased. But somebody, coming from some Facebook or Instagram and then getting landed to your website, there is a less possibility that they will buy. So they just randomly sitting, relaxing, and they somehow, they come across a reel, where they have seen some kind of a product and then they landed to your website. There's a high less chance, they may. So there could be a lot of patterns. I'm just giving you an example. There could be lots such kind of patterns and scenarios which the model will learn from the historical data. And then, with that knowledge, it can able to predict which shopper has a high propensity to buy. And you might have seen that now, if you go to any retail store, now the people, the salespeople, they have that knowledge. They can easily gaze out, who is a serious buyer, who is not serious buyer, and their and the way they attend the customers will also differ because they can decide or they can predict, okay, which buyer is more serious. Okay, because they have seen, they have met, or they have handled so many customers in the past, they know, they can easily make it out. Okay, so here also, if I build certain models based on the past purchase history of the shopper, like shopper characters like age, gender, income. So people like who are, it's nothing, I'm not gender biased, but females basically they do more of window shopping. There's less propensity to buy if because they have multiple things to consider, right? But males, they generally go and they buy it. Okay, typically if you talk about me, if I get into any Amazon online shopping, I'll go for a limited time and I will buy my stuff and I'll come out. If I see my wife, okay, she like hours together, she'll keep looking. She will go for some product and she will end up buying some other product. Okay, so that's like that. So that characteristics are also important. Okay, so even the age, even the income, okay, all these things could may impact whether the people will buy the product or not. Okay, and the seasonal information also. If there is any festive season, there could be the high chance people buying the product. So there could be multiple other factors. So in the past, I need to consider all those factors, all those characteristics, all those attributes, and based on that, I need to train my model, which can able to predict whether the person will buy my product or not. Okay, so I'm kind of creating a virtual intelligence or artificial intelligence, which I will put onto my website, which can predict whether the shopper is serious or not, and then accordingly I will offer them the chat help. Now this becomes an AI solution, but here typically what I'm using machine learning, to build that predictive model. Okay, so when any new shopper is browsing, it will predict if the shopper will buy or not, and then it will offer a chat help. Now, one more example use case with this I can remember is everyone must be getting all those marketing calls, right? People will come and approach you for credit cards and for lands and for some kind of an investment. How they are doing? There's so many people in Hyderabad. Why they are calling you only specifically? Definitely, probably they are using some human intelligence or some artificial intelligence. Human intelligence would be they would be having some kind of data of yours, sitting with them. They know that okay, you hold a account, you hold a credit card, okay, you have a good income, and you have invested recently somewhere. So they will have some information, some details about you, and based on that, they're making a call. And generally, if you see, if you go to the now, data collection is also becoming a new field now. You might be observing, or you might have experienced that when you enter into a mall, people will give you some kind of a pamphlet. Okay, this is a different techniques, okay, to collecting the data. And I would advise you don't give your number anywhere, okay, phone number. Usually people will say that okay, there is a lottery, there is something happening, okay, fill your details, okay, we will give you a call, if you win. That is not the intention. Their intention is to collect the data. I don't know if somebody has won in those kind of uh, things or not, but just imagine how much data they can accumulate. And what they will do is now they will go and sell to other people. And this data is valuable. They are just employing 2 or 3 people, okay, into the malls, and they're asking them to stand and collect the data. But that data is getting sold in lakhs. Okay, trust me, guys. Okay, so now they know that the people who come into the malls, they will be well off. Okay, they will be having a good income. Okay, and all those things. That's the reason they are coming to costly malls and they are kind of spending amount. So their target audience, they will get it. Let's suppose they get 1,000 or 10,000 phone numbers, and now they will go and give it to some real estate realtors, okay, or real estate businesses, saying that okay, now these are the 10,000 phone numbers, okay, you can target those people. Okay, so there's a possibility that they may buy, or they may give it to bank. So with this data they will earn lakhs, so their job is done. Okay, now they will go and they'll start making a call. Just imagine, out of 10,000, if 10 people also agrees in buying a land, okay, it is a profit for that company, right? So that's how, the data has become so much valuable. Even the data collection has become very important. Okay. So, and you will find different ways through which people are kind of generating and collecting this data. Even these are telecom services companies. Okay. They are also selling the data. Even the apps, the free apps, which you use. So they will have access to everything. They will also, why they access your contacts? What's the purpose of accessing your contacts? Right, but we give, okay, just in a hurry, we give complete consent, okay, and we say that, okay, we agree. You go and access my images, my contacts, my messages, everything. When they access your messages, what they will get? They will also get the details about how much salary is getting credited onto your account. So they will get access to that data, and then they will start mapping it. Okay, so your income is this much. Okay, with based on the contacts. Okay, they will get other contacts also, and everything. Most of your private details will be accessible to all these app owners. And now these apps, just by giving a free app, they have collected a lot of data from you and then sell that data. So that's how the trend is going on. Guys, my internet seems to be or my voice breaking. Guys, am I audible? Hello.
Yes, now we can hear you.
Just a second. Let me change my network. Earlier, was it with my network?
Yeah, it's audible, Srikant.
All right. I think now it's better, right? Please confirm, guys.
Yes.
Perfect. Okay. Yes, so I hope you got this particular use case. Okay, so now there are multiple use cases on even on we call it as digital analytics where you can collect. And now you'd be wondering like how this information on online we can get. So there's a lot of different tools like Google Analytics which can track the entire footprint on the online business. It's quite easy to understand from where the traffic is coming, the person is coming, and how long they are being on your website, what all keywords they have used, to search for the product, how and what feedback they have given, everything, digitally it is possible to track everything. But when it comes to um um a live retail outlet, offline business, it is difficult. Okay, offline business is quite impossible to track the complete footprint, because anybody coming to your retail store, you don't have any idea from where they have come, right? So but online business, it is easy. So predicting the next move or predicting whether the customer is serious or not is comparatively easier on the online business, and you can do a lot of things on the digital front. So we call it as a digital analytics or web analytics, okay, where you can build a lot of AI and data science solutions, in which this is one of the use case. Now comes to banking. Okay, in the banks, these are some of the figures, and it is now outdated also, but now it is much more higher. Okay, so earlier, because of this uh, reduction in the false alarms, okay, so there are more. So you are seeing, right, how this what you call frauds are happening, right? Cyber crimes are happening. So how the people, the fraudsters, they are kind of making some frauds, in and then they are doing some fraudulent transactions. Okay, and people are losing a lot of money. So there is an increase in the frauds are happening, and simultaneously there is an increase in fraud detection. So 50% there is an increase of fraud detection, and there is, and with the help of data science, there is an AI solution. 50% there was a reduction in the false alarms. How it has impacted the business, I'll tell you. Earlier, if you have to make a larger transactions, you are not supposed to do, through online. You have to go to the banks only, and then only they will allow you to make those kind of transactions. Okay, even there are certain limits, but now the limits they have increased. Okay, so now you can do a higher amount transactions because now we have a more sophisticated way and solution, to identify or to detect any kind of fraudulent transactions. Earlier, it was like humanly they were doing, or they were using some kind of a very naive or basic logic, to detect the fraudulent transactions. So, so there's two kinds of impact. One is like, okay, if the transaction is really a fraudulent transaction, then it is good. It is good for both, for the bank as well as for the customer, right? So customer will save the money, even the bank will save the reputation, right? So if it is a false alarm saying that, okay, this unnecessary, the customer will get annoyed, obviously, and the bank's reputation will be on stake because they don't have a better solution. They don't always, for every transaction, they are raising the alarm. Okay, so people will get annoyed. So this will also impact the overall business. Okay, so now the banks, they are looking out for some more sophisticated way, to detect the fraudulent transaction for fraud detection. It will minimize the risk and it will also maximize the customer satisfaction. So there is a 50% reduction of false alarms because of this kind of solution. And as overall, it has saved 60% of the cost, okay, or the savings. So this is a use case, which is from one of the large US bank, where they have used IBM machine learning technologies to analyze the credit card transaction, and has resulted in the following. Okay. Now this is one of the use case, and this is very old facts. Okay. Now currently even much more, the numbers will be much more higher. Um, so so you're seeing, right? Okay, how even the banks, they are using the machine learning and AI. It's all about predictions. Now you have to understand, if you know the use case and if you can able to translate that into analytical problem, and you can come up with the right techniques and right approach to solve that problem, it will impact the business. Now just imagine if you are that person, who has trained this model, and if it is saving 60% of the savings for a bank, would they mind giving you a good salary? Okay, and just imagine millions of amount of money, you have saved. You'll become a rock star, okay, and they will make you kind of a risk, the head of risk, okay, CRO, Chief Risk Officer. Okay, so that's the, and I've seen people, growing that rapidly, okay, in the businesses. Okay, so they have come up with one unique solution and they have deployed it, and it has impacted a business a lot, and they have got promoted to the higher levels. Okay, so this is from the banking side. This is the most commonly experienced use case. Okay, we all experience in our daily life. You might be using Netflix or Prime Videos or on Amazon. Everywhere you will see recommendations, right? And this is a common thing, okay, which we see in any of the e-commerce website. If you buy one thing, immediately before purchasing, they will give you some kind of a combo saying that people have purchased these two things together. And then you will realize, oh my God, oh yeah, I didn't even think about it. Okay, this looks good. Okay, and they are giving a discount also if I buy these two together, right? And what you will do? You will end up buying. And this happened with me multiple times. I think about something and I'll go and it will recommend me along with that something else would be also useful. And then I will end up purchasing those two or three products accordingly. Okay, along with that. So everyone might have experienced this. So how this is doing? Okay, so there are certain association rules. There is certain item collaborative filtering algorithms. What it does is it will look at the past, again, historical data, and it will see that how many people they have bought these two products together. If somebody has bought mic, how many people have bought the mic stand also along with the mics? Okay. Okay. So microphone along with the stand. Okay, how frequently people have bought together. If it shows as a recommendation, then there is a chance that people may end up buying the second product also. And how it will impact. See, the business needs not to invest too much on this. Okay, just the business requires one server and one solution which needs to be deployed on that server, right? And one initial investment in terms of developing that solution. That's all. But it would run 24 by 7, okay, 365 days, okay, on your website. And just imagine, how much more revenue it can generate. If somebody is coming out for microphone and if he end up buying a stand, still it is a additional sales, okay. So there is organic sales and inorganic sales, right? So organic sales is people are coming and buying their own product and they are going. Inorganic means something it's like push strategy. You are pushing certain products to the people to buy, okay? And that you are using recommendation system. Okay, so if somebody is buying one additional product, that's a additional profit, right? So and this kind of solutions, they are kind of helping the business a lot. Okay, they are amazing solution. Okay, and the value what businesses are getting out of this recommendation is too high. If you look at YouTube or now Instagram, you go and go for one particular video, but you end up viewing 10 different videos. Okay, so for 10 different videos, they got additional, views, right? So that's how the businesses, they are driving more sales, more views, and all those things. Okay, and see, now this is one of the case, but even another use case, when you go to the supermarket, okay, there would be certain combos, right? Even in the McD's and Subways, you go, you will find some kind of combos. How they're coming with the combos? It's not something like, okay, they are just seeing the past data and seeing that what are getting more, uh, you know, being more sold. No, they are looking at the association. If somebody is buying a burger, how many people have bought, French fries along with that? If French fries also, and how many people have bought a Coke or a Pepsi along with that? Okay. So based on that data, okay, again, it's not as simple as this, okay, the way I have explained, but you will find we will discuss about the association rules, which is also called as market basket analysis, where you give all the transaction data, and within fraction of seconds, I would say, it will give you the complete, uh, relevant associations between the products. And you can choose, which combos, you want to go ahead with. So we have those kind of algorithms which are very fast, okay, and very quickly, it will extract the information and insights from the data, and it will solve a kind of a major problem of a business. Now, once you have the associations with you, how the products, and it's not just one or two products, it can find the associations between hundreds of products. So it is scalable. And with those association, you can take a lot of decisions. Like in supermarket, you might have seen that, okay, firstly, they will sell multiple things in combos and say that, okay, price 99 or price 299, okay, where you will get 1 kg sugar, 1 liter oil, and 1 kg onions, right? Something like that. Because most of the time, people coming to the supermarket, they're buying these three items together. Okay. So it's a very easy way, to sell all the three products together by putting that combo. The people who is probably is not even thought of buying onions along with this sugar, this oil and sugar, they'll go end up buying the onions also. Okay, and the other um usage of this kind of models is in placing the products in the supermarket. Which one to place in the front aisles, and which one to place in the back aisles or the shelves. All that can decisions can also be made through association rules, okay, which we'll again discuss in the class when we talk about that. Okay, now this is one of the solution around the operation side now. Now, for example, you are running a call center, okay, and uh, you need to optimize the usage of your or optimize the productivity of your call center agents. So every agent will not be equally equipped or equally experienced, right, in taking up the calls and in addressing the customer queries. Everyone will have a different skills or different maturity in terms of resolving the queries. Now, how can I optimize that? I'll give you a scenario. Let's suppose if there is a very complex query, okay, complex problem, okay, the customer has, and that call has routed to a person who is just joined, recently joined. Definitely, he may not be able to solve that problem. And at the same time, the customer will get annoyed. He will ask unnecessary questions and he will put that call on hold. He will go and check with the senior. Okay, again, he won't be able to explain it properly back to the customer. Okay, the customer will be always, will be in the explaining mode and he will not able to get any resolution out of that. So too many issues, right? And what if, if there is a very simple queries and if it is going to the experienced candidate who is like 10 years and 20 years, he may feel that, okay, what a silly problem, it has come to me. Okay, this could have solved by any other. And he may not show interest also in solving and all that things may come, right? So a proper utilization of the resources you're not doing. And ultimately it may hamper your productivity, your quality, as well as the customer satisfaction. So here also you can use, so you remember the prescriptive analytics I talked about. What should be done, right? If I'm getting 10 calls, if I have 5 people in my team, okay, who can handle the problems, how I can optimally route those calls to the right people so that, these calls can be addressed quickly. There comes the prescriptive analytics. Here I will run the optimization models, which will score the callers as well as the agents, okay, based on their past history. Okay, if I am the caller, who always call if I have with a complex problems, so my score would be high. Similarly, the call center agents, based on their experience, based on the kind of queries they have handled in the past, there could be some kind of a scoring which can be done on the call center agents also. Okay, so based on the scores, if the customer with a complex query coming, okay, the model will score it and it will route it to the person, who has the highest score in terms of resolving the query. So now this could be optimized. So all the business outcomes will be optimized because the right callers are then matched with the right agents. Okay, and your business will run smoothly. And now, even further, a lot of solutions are being developed in the call center area also. Recently, we developed a solution known as call center analytics. So what happens is uh, all the recordings, voice recordings, and the interactions made by the agent with the customer are kind of recorded and saved, and that can be used for further auditing and for further improving the process. So it would be a lot of text data, definitely, right? If it is voice, then we have to convert that voice into text, and it is completely a text data. Then you have to use the NLP, natural language processing techniques, on that text data to, validate, how smoothly that call has happened and how nicely that call center agent has able to resolve the query. So there's a different techniques. I'll give you a very simple example. For example, if I am a customer, I was very angry with the service, and when I make a call, I was very angry. My voice, my tone, and even the kind of language I was using was very furious. Okay, that I can detect through some natural language processing. Okay, with the text, with the words. Okay, I can able to find out the emotion of the customer, and even I can find out the sentiment of the customer. So let's suppose it is completely negative. Now, let's suppose that call went on for 10 minutes. Okay, in the 10 minutes, after that, the voice mellowed down, my voice mellowed down. And in the end, I was kind of happy and I was start thanking that person. So that means my sentiment was positive. And all these things I'm doing with certain algorithm. Okay, beginning it was negative and then it become positive, then it is a good, and he has done it in 10 minutes. Okay, so that is a scoring. Let's suppose if there is a call, there's a call who was like kind of disappointed. He was not extremely negative, but he was very politely putting a point, saying that, okay, I was not at all happy with your service. Okay. This is something I was little disappointing, but rest of the other things was good and everything. He was explaining. But this agent was showing some attitude. He was not responding improperly. His sentiment or his emotions further got negative, and in the end, he blasted that agent and then he ended up the call. So here the sentiment was negative to extremely negative, and it happened in 5 minutes. So now this is where the person, the business will look into and start focusing. So now all these things, you imagine, it will happen in within few minutes. As the call gets over, within few minutes, all these details will get passed, to the operation manager, and he quickly able to take the corrective actions, rather than before, like, you'll randomly select some audios and recordings, and they go through manually and then understand who is spoke what, so that all things got resolved now in the call center. There's a lot of other use cases which I can tell you. Now we are using generative AI, where we are using virtual agents along with the real agent in the call center, and we are continuously comparing whether virtual agents are responding better or the real agents are responding. In whichever areas the virtual agents are doing better, we are replacing those virtual agents with the real agents. So all that things are automation and business process improvement, and all those things can be done, in the call center area. I hope you can relate this. Now, finally, in the government sector, okay. Now you might have seen this COVID and all. Now you might have seen the news, if you guys were following the news at that time. Firstly, this outburst happened in China, right? Now, there was some kind of a prediction being made that, okay, by next 3 months or next 4 months, this is going to affect India as well, right? And then the government started taking actions. They were closing all the borders, and and they were not allowing people to travel, and all those corrective measures they are doing just to delay that outburst. But it has happened. Okay, so there are certain if you have the right data, you can able to see that if some kind of pandemic is happening, how fastly it may spread based on the data from China to some other neighboring countries. Let's suppose it has took this much time, okay, and in some other areas, in some other part of world, it took this much of time. If we have that kind of a data, looking at our neighboring countries, we can also predict like how much time it may take, to affect in my country. And then in with that speed, with that agility, our government has to take actions in terms of preventing that particular pandemic, or taking all the preventive measures in terms of preparing the hospitals, preparing the beds, or the medicines and all those things. And we have kind of experienced that, okay, during the COVID situation. The government has done a great job in terms of planning and in terms of taking all that preventive course of action. So there also there is a use of predictive analytics. This is one of the use case, but there are so many other use cases, like how the inflation may affect the economy, how the other factors, weather would impact the thing. So you might be seeing a lot of alerts coming, right? Today, this time monsoons will be this much, and the government will again take the preventive actions. So even in the government sector, there is a data scientist. If you, I don't remember, there one Indian guy, who was a chief data scientist in this uh, Obama period, I guess. Okay, Dev Patel. Yeah, his name is Dev Patel. You can go and search for him. He is the chief data scientist who used to work, okay, for Obama campaign, or I don't know, someone else. Okay, so even now this all these leaders, okay, chief ministers or prime ministers and all those things, they are hiring a data scientist. Why? Because they are helping these leaders, to take the right decisions. Now, if you see Modi, there is you can find a blog also. So he has used the data science and AI, to run the campaigns. He knows, what sentiment the people with what sentiment people will be convinced. Okay, so he has used all those things. So he's too much available on the digital side, right? If you see all the social media and everything, okay, his presence is there, and he's using a digital things a lot, to reach out to the common people. Okay, so he knows the power of that, and he has hired the complete team of data scientists, who continuously who look out the social media data, they analyze it, they bring out the insights, they find out the problems, they find out the sentiments of the customers of the citizens, and then accordingly the government is kind of touching those topics or those areas, and that's how they are reaching to the common people. So yeah, so roughly I've selected these many use cases only. By now you might have understood, like, how this data science is getting utilized or adopted in different kinds of domain. Okay, so we talked about digital, we talked about banks, we talked about call centers, we talked about government. So that's the adoption, and in every business they are at the different stage of adoption. We call it as AI adoption journey, or digital adoption, or digital transformation journey. So every company or every country, okay, in that matter, is kind of getting matured in their digital journey and in their AI journey, adoption journey. Few companies, they are much matured, like Google, Microsoft. Okay, they are even the what is it? Creator of these. Now, Google themselves, they have a huge R&D team. They build new algorithms, and we are the consumers, and they have huge amount of data. Like Google, see, the data is coming from Gmail, the data is coming from Android, the data is coming from YouTube. So they are having so much of data, so they are developing, they are the disruptors. They are coming up with the different products, okay, which can disrupt the entire uh, you know this field, okay, because they are coming with different algorithms and all. Even the Microsoft, even in that matter, Amazon, okay. So they are the generator, they are creating the data, they are creating the algorithms, they are kind of disrupting the whole existing traditional way of doing things. So they are pioneer, okay. So they are the veterans and they are the leaders, okay, in this field. So they are in very much mature stage. But there are certain other companies, like who are the consumer of all these different technologies. They might be at the different stage of maturity. Few people would be just early adopters who are just preparing themselves. Okay, probably they don't have the enough data also, so they are seeing how to they can get into digital, and how they can generate more data. Few people will be little more mature, they have kind of they find all the ways possible to generate the data. Now they are struggling with managing and storing that data. After that, there would be certain customers, who have started the descriptive analytics journey, okay, and then they are getting into predictive. Few people might be even much more mature. They might have developed certain AI solutions, they might have developed certain computer vision and NLP solution, and they wanted to further you know scale themselves and improvise their existing solutions and products. So in every domain we have this kind of maturity. So you will find early adopters, you will find the matured businesses in every field. Even in the countries, if we compare with us would be much more advanced than us in terms of adoption, but we are moving towards that. Even in the businesses, in every sector, in pharmaceutical, in automobile, in banking, okay, if you banking, Swiss banks would be much more advanced, because there the risk would very high, right? The banks, like small banks, their adoption would be less. So, but opportunities are everywhere. Okay, so that's what I was being telling you guys. You can target any industry, any businesses, any company. Okay, even in the government sector, okay, there is opportunities. So that's how there is a huge demand of you'll see a huge demand of data science. So with this, I will stop. I can take a couple of questions if anybody is having. Anybody is having any question?
Yeah, hi Shrikant, this is Anusha.
Yeah,
Uh,
good.
so I missed the earlier demo classes, but I have a couple of questions. I don't know if you they were part of the other introductory classes. Just want to know this.
No issues.
So,
Go ahead. Go ahead. Yeah.
so you mentioned about the generative AI. So I want to understand what is generative AI? How is it different from the AI? So I understood that uh, feed the feed the machine with all the data and then let it make the decisions on whatever the existing data based on the
Right.
existing data. So what is about the generative AI?
Okay. I'll explain. See, AI, if I put it in this way, AI, what it does is it takes the data, okay, and then it will train the model, and then model will give the predictions. Basically, it will take the input, and then, according to the input, it will act. Now, when it comes to Gen AI, generative AI, these are all pre-built models. You need not to train these models. When you talk about GPT, GPT 3.5, GPT 4, or any other Bloom, Falcon, okay, Llama, all these things are large language models which have been already trained by people, on a huge amount of data. Now, this OpenAI company, they have trained these GPT models on entire website data till 2021. Okay, they have taken all the different kinds of data, like for the code purpose, uh, they have taken the data from Stack Overflow, from GitHubs and all, and they have trained one model which is known as Codex. Now for images, they have trained certain kind of models, okay, which they called as DALE. Okay, for on the text data, they have trained a large language models, which they are calling as GPT 3.5. Now, what later they have done is they are coming up with the GPT-4 model, which it is a multimodal, it is a multimodal solution in which there is a large language models and there is a diffusion model. Diffusion models are primarily has been trained on images and the videos. So they have combined it together and they are now giving it as a GPT-4 models. To the GPT-4 models, you can pass the images, even you can pass the text in the prompt. It will understand both and it will respond. Earlier, it was taking only text and it will responding only text, right? Now with this GPT-4, you can pass text and get text, you can pass images, you can get text back or images back. Okay, so it's a kind of a multimodal solution. So now if you see in all these things, what is happening is now this generative AI solutions are generating the data. They are generating the text data, they are generating the images. If you have used the chat GPT, you just say that, okay, can you come up with some kind of a material or some kind of a description about this particular topic? Instead of you going and searching and creating that whole content, the chat GPT will create the content for you. Even the resumes, it can generate, if you give the right prompt. So just by prompt, it's just like giving instruction and the chat GPT is doing your task. So it is generating. So that's the reason it is called as generative AI. But again, there is a AI model, okay, which comes under data science. Okay, there is a model, but these are much more advanced neural networks which we call as transformers or autoencoders, which we use, to build these kind of models. So the major difference between AI and generative AI is in AI, you have to train the model on your past data, but in generative AI, these are all pre-built models which we are using, and definitely we have to make some kind of a customization. If I want to implement some generative AI solution in my company, on my documents, on my custom data, I have to do some kind of fine tuning. So I can leverage these models as is, and I will just do a little bit of fine tuning by passing my data to these models. I can tune these models. Now these models can able to answer my questions, my specific question related to my domain. Okay, so that's the reason now this entire field has been separated from a traditional AI and they have been called as a generative AI. Because through the prompt, with the help of the prompt, you can able to generate text, you can able to generate code, you can able to generate images, you can able to generate videos. Everything is possible now with these models. But still, there's a lot of discussions are happening. How can we trust this? Okay, if it is answering something, okay, how true it would be, okay, how correct it is, okay, that we are not sure. Now, even you might have seen ChatGPT. ChatGPT is not always correct. Okay, sometimes it will give some vague answer. Okay, uh, which could be incorrect, right? So now still a lot of work is being done. Okay, now various, and it is a race. Now once OpenAI has released his own generative AI model and named it as GPT, so now there are multiple other vendors. They also started building their own. So Amazon has come with Titan. Now Google has come with Gemini. Okay, and Palm. Okay, Microsoft has acquired completely OpenAI, and they are using OpenAI's models only. Now Databricks, they have come up with Dolly. Okay, so every company, okay, who has some kind of infrastructure, okay, basically the cloud vendors, they have the infrastructure with them. They can train the models, okay, in their on their servers, and they also have a huge amount of data. So it has become easy for them, and they went and they trained the model, and they are selling these pre-built model as a service. OpenAI, what he's doing is he's selling GPT models. That's all. That's his service, which he has trained. We call as a model as a service, MaaS. So this is what is generative AI in short. Okay, in AI, you are training the model yourself. In generative AI, you are leveraging the pre-built models or the LLM models.
So, as part of this course, how much are we going to cover the generative
No.
AI?
So see, this is I also answered this question in multiple initial classes. See, this is
I was
a
not.
basic course. Okay, it is a 2.5 months course. You need to understand that in this 2.5 months course, covering all the topic is not possible. That is reason for first reason. Second thing is, I'll not advise you know to get into generative AI at this moment until unless you have a good understanding about the basics and about the fundamentals, because this generative AI is a complex topics. Okay, as I mentioned, these are complex neural networks, like transformers and all. You will not able to understand the transformers until unless you understand the basic neural networks. And to understand the basic neural networks, you need to understand the statistics and mathematics. And to understand that, you need to go through all the basic concepts of statistics. So in this course, in this 2.5 months course, we will take you to that extent, okay, on top of which, you can start building your skills. So if you want to get into generative AI, still you can do it, but it will take a little bit of time, but it would not be something, okay, like Geek or Latin for you, because you have learned the basics. You can, if you can relate or correlate all those topics, you can easily able to understand the generative AI. Okay, and you can get into that path. Even if you want to get into the path of NLP and computer vision, you can able to get it because you have understood all the building blocks of all those concepts. So you can easily sail through and you can able to understand those concepts. So even on the IT side, we are covering Python and PySpark in this course. If you understand this concept, even getting onto the cloud and understanding those cloud services would be easy for you. Okay, because on the cloud, most of the things can be done through Python. Okay. And if you are doing some real time analytics over the cloud, there also you can use PySpark. Okay, on AWS, let's suppose you are going with EMR or else you are going with Databricks. There you can use PySpark. So just consider this as a basic and intermediary level course where we will cover the topics, all the topics related to data science to a level from which you can go ahead and you can start building the expertise around it.
Okay.
And as I mentioned, after this course, you can look out for a job for till 4 to 5 years level of experience.
Yeah.
Okay.
And one more thing. So, when the course gets started, so there will be daily. You can will you share us with the PPT or some material or something to or
We
some
started from
webinars to
Wednesday, and
prepare?
from Wednesday till date, okay, we haven't got into the subject. We're just talking about what could be possible with data science, what are the different jargons we hear in the space, and we were taking some questions, all those things. So actually, the real course has not been started yet. Okay, but however, after every class, okay, there would be a recording. Okay, and the class will get recorded and the recordings will be shared with you guys. I'm not sure, until unless you enroll for the class, whether the institute will share those recordings with you or not. If you are enrolled, then I think past recordings will be also shared with you. Okay, and we will also share the handouts. Okay, soft copy of the of all these topics along with the source code and the data. Okay, and we will be covering more than 12 to 15 use cases in this course, where you will get an idea, about how the problems can be solved in the real scenario.
Yeah. Thank you,
Okay.
Sri.
Yeah, thank you. Any other questions, guys? All right, then thank you. And tomorrow it would be off. So Sunday will be off. So we will connect on Monday. Have a nice weekend and a nice day. Thank you so much. Take care. Bye-bye.
Thank you.
Thank you.